going to talk about continuity, which is taking the idea that we've been using with limits and going just a little bit further. So we're going to look at a little example here. Let's say we got a river, and we need to call in a team of engineers to get over this river. So, you know, if you got a river here, you're going to need a road coming this way, a road coming this way, and then a bridge to get over the actual river. So we're going to call Jonah Engineering. Jonah's company comes in, and, you know, we got our imaginary river there, and he builds a road coming this way, and a road coming this way, but he doesn't build a bridge on either one of them. And the roads don't meet. So we fire Jonah. And then we call in Contreras Corporation here to try to fix it. We're like, look, Jonah didn't even build a bridge. Let's take care of that. So Maria comes in with her company. She builds a road and puts the bridge at the end of it. We're feeling pretty excited. And then she comes back the next day and builds a road that doesn't meet, and the bridge doesn't go in that spot either. So she gets fired. We call Blaine Davis's engineering crew. We're like, look, we got Jonah Maria company in here, and they can't even make the roads meet. At least you can hopefully handle that for us. So Blaine's like, sure, I got that, no problem. You know, puts two roads together, packs up his crew and leaves, thinks he's done. I mean, we got no bridge. We're still stuck. We got people on either side of the river, can't get over it. You're fired. All right, Miss Cole, come on in here. We got Blaine building roads that they meet, so we're making progress here, but we don't even have a bridge. So Courtney comes in, builds two roads that meet, tells her crew, hey, build a bridge for them. They put it in the wrong spot. So finally, people call Davis company. I come in, knock it out, build two roads that meet, put a bridge in the middle, and we're all good. And so this example right here is the only one that is an example of a continuous function at the given point. So for something to be continuous, and we'll go back and look at those other examples in a second. Number one, the limit has to exist. At that point. What that basically means is the roads have to meet. So if we go back and look at who had a problem with that rule. So whose construction did not have the limit exist or didn't have the roads meet. So Jonah's roads don't meet, the limits don't exist. Not continuous. Maria's roads don't meet, the limit doesn't exist, not continuous. Blaine's roads do meet, the limit does therefore exist, even though there's no bridge, it doesn't matter. If the roads meet, there's a limit. So he's good on that but we got two more that we got to worry about, and he's not going to get all of them. And then Courtney also, the limit exists, the roads meet, so she's good for that qualification, but she's going to drop out later. And then this one's good. All right, the second thing is f of c has to exist. And what we're calling c is like the x value in all of these. So there's like an x value of c there, an x value of c there, an x value of c there. And what that means, there has to be a bridge. There has to be a filled in dot at that x value. So Jonah's no good. Maria's got a bridge, but her roads didn't meet. Blaine's no good. Courtney's got a bridge, but her roads met. So actually she's got she got both of those. She's missing the third one though. And then I've got a bridge and my roads meet. And the third thing is your roads have to meet, and there has to be a bridge. And then those have to be at the same spot. So the limit has to equal f of c, or the roads have to meet where the bridge is. So Courtney was good as far as the first two, but she's missing the third one. So the roads meet, there is a bridge, but they're not in the same spot. So this one is the only one where the roads meet, there's a bridge, And that all happens in the same spot. And then all three of those things have to be true for something to be continuous at that point. All right. Oh, I wasn't even on the screen there. Let me pop that up there. Give me a second to copy it. Sorry about that. Alright, so what you're going to get is graphs that ask you a bunch of questions about limit from each side. Does the limit exist? Is the function continuous? What's the value of the function? Stuff like that. So let's say just kind of drawing out something here. Say that's 1, that's 2. We got kind of this thing going on. So I'm going to look at an x value of 1. So what's the limit as x approaches 1? Let's call this function g of x. What's the limit as x approaches 1 of g of x? Well, I'm looking at both sides. As I go towards an x value of 1 from this road, we're going toward a y value of 2. As I go toward an x value of 1 from this side, down the road, we're going toward a y value of 2. So the limit is 2. I don't care where the point is, I care where it looks like we're headed. And from both sides, it looks like we're headed toward a y value of 2. Alright, what is the actual value of the function when x equals 1? This is where's the closed dot, where's the bridge? What is the y value of the bridge or the closed dot? So at x equals 1, the dot is down here, which has a y value of 1. Now, if these two are the same, the function is continuous at that spot. If they're not, it's not. So is g of x continuous at x equals 1? Your answer's got to be no, because these two are different numbers. All right. Another thing you could be asked to do with that is to tell me where the function is continuous. So instead of looking at a certain spot and saying yes or no, tell me the whole range of values where that function is okay, where it is continuous. So the road is nice and smooth and there's no holes, there's no issues at all, anywhere except for at x equals 1. So like right there, the limit would be the same thing as the value because the road just goes right through that point. And everywhere here, there's really technically closed dots, like every single point on this line. So everything's fine, everything goes right through that dot, except for here. So what we want to say is this would be continuous on 0 to 1. And this is a bracket because we are continuous at 0, because the closed dot is right where it's supposed to be. And that means we include 0. This is a parenthesis because we're not continuous at x equals 1. Parenthesis means we don't include the 1. And then we are also continuous from 1 to 2. Again, not including the 1. And then going all the way up to 2. We do want to include 2. Basically, this is saying everything between 0 and 2, including the endpoints, but not including 1. Alright. Let's do a similar one here. Let's say this is h of x, and this is an x value of 1. I kind of ask you the same stuff. So, what's the limit as x approaches 1 of h of x? Well, if I looked at it from the left-hand side, we're going towards a y value of 1. If I look at it from the right-hand side, we're going towards a y value of 2. Because those are different, your limit has to be does not exist. What is g of 1? Again, g of 1 is the closed dot, or the bridge. So what is the actual y value of the closed dot when x equals 1? So read up here. This isn't it, because that's an open circle. This is the one you're looking at. So the y value at 1 is 2. And then is h of x, this should be an h, I'm sorry, continuous at x equals 1? Well, first of all, the limit would have had to exist, and then these would have had to be the same. The limit doesn't exist anyways, so this is definitely no. And then I would also want to look at where is the function continuous. So in this case, we would say negative infinity to 1, and 1 to infinity, because there's nothing wrong with anything else over here. The roads are connected, we're going right through the dots, there's closed dots everywhere. We don't include negative infinity. You cannot say we're cut off at negative infinity, because whatever number you say negative infinity is, I can give you one that's further to the left. So you say, you know, what about negative 99999? You can be like, well, alright, fine. What about negative 9999999? You can be like, okay, if you're going to play it that way, screw you. How about negative 9999999? And we can just keep going that way forever. So you can't cut it off. So when you deal with infinity, it's got to be parentheses. Alright. Alright, I'm going to stop there and move on to the next thing that you're being asked to do. And I'm just going to, for this one, these are really hard for me to write out. So I'm going to grab a question or two from your homework and just go through those that way, and then hopefully that helps you with the rest of the ones from your homework. So this is one of your worksheets. I'm going to go through this problem here and explain it. I'll do one more, and then hopefully that is enough to get you started on the rest of them. So this is a composite function. So this is f of g of x, and we're looking at the limit there. So we're going to plug 2 in. We're really looking for the limit of f of g of 2. So if I look at 2, the next value of 2 on the graph of g, as x approaches 2 on the graph of g, what is the limit? Well, from that side and that side, we're going towards a y value of 3. That's your limit. So this value in here, we can kind of cross off now and say that's 3. Now I want to know what happens when I plug 3 into f. So I'm kind of working inside out. So I take the 3 that I got from this graph and I plug it in over here. So if I plug 3 in over here, and I'm looking at the limit still, so what is the limit as x approaches 3? Well, there's no open circles or anything, and all I gotta do is kind of look at the value. So this would be a y value of 2. And I've already got circled, but that's your answer. So you're taking the x value, look for the limit in the first graph that they give you, in the inside one, and then take that answer and find the limit in the second graph, whichever it is. Right, let's look at, let's do this guy here. So the limit as x approaches 1 of f of x. I'm going to take that 1 and plug it into f. F is this one. If I look at x equals 1, that gives me a y value of 0. So then I want to take the 0 and go back to this graph, go back to your h. So if I go to 0 on this graph and read up, that gives me a y value of 3, and there's your answer. You'll notice quite a few of these are does not exist, because if any part of the question gives you does not exist, your entire answer is does not exist. So for example, in this very first problem up here, as x approaches negative 2, so if I look at the limit in the graph of g at negative 2, that's no problem. As x approaches negative 2, you know, we're coming toward it from this way and this way. It looks like it's going towards a y value of 0. All good so far. Problem is, if I go to 0 on this graph and look for the limit as x approaches 0 here, we get a different answer from each side. So I get that from one side and that from the other side, and it doesn't exist. If your first value didn't exist, you couldn't continue. If your second value doesn't exist, either way, you end up with a D and E for your answer. And then I'll leave the rest of them for you. And there's one more type of thing here, and I'm just going to do one of these because we've kind of talked about it already in the notes. Let's look at the very first one on here and check off the boxes that we think need to be checked off. So they're interested in an x value of negative 5. So we're looking right here to see what's going on. So this says the limit exists from the left and from the right. Well, from the left-hand side, is there a y value that we are heading towards? Yes. It is a y value of negative 3. From the right-hand side, is there a y value that we are heading towards? Yes. There's a y value of negative 3. So this one's all good. Does the limit in general exist? Yes, because these were the same as I came from either side. is it defined at x equals 5? Means, is there a value at x equals -5? Is there a bridge at x equals -5? And there is. It's up there. It's not where it's supposed to be. This is like the Courtney company. It is defined, but it's not where it's supposed to be, so it is not continuous. For that to be continuous, this dot would have to fill in that circle. Alright, so I'm going to leave it there. I want you to, do both of these, bring questions, and we'll go through that stuff tomorrow.